Projectile motion is probably one of the most common applications we see in quadratic equations. Well, what is projectile motion? Projectile motion always involves, like, say we're standing on the top of a building and we decide to throw a ball off of the top of the building and the ball travels. Well, what is the ideal shape that anything you throw through the air makes? That is a parabola. So we can model throwing anything pretty much using a parabola. So this is a very, very common thing for us to do. For our purposes in our class, they're going to give us lots and lots of words, but they're also going to give us an equation. And that equation is what we're going to want to focus ourselves in on so that we can solve the problems. So let's give this first part a try. An object is propelled vertically upward with an initial velocity of 20 meters per second from the ground. The height of the object from the ground at time t is given by the equation negative 4.9 t squared plus 20t. Part A, when will the object be 15 meters above the ground? Okay, so we definitely want to focus in here. Now, does this 20 meters per second mean anything to us? No, it does not. It really doesn't. It's kind of showing us where they got the equation from for the height of an object. When we get to calculus, this will actually be very obvious how that came about. But for now, we're going to kind of leave it where it is. So we're going to use h of t. And what does h of t mean? It means the height at a particular time. And if we look at part A, what did they give us here? Did they give us a height or did they give us a time? They gave us a height. So we're going to go ahead and plug this 15 meters in for. Now remember, when you plug in for something that looks like h of t, that's one big thing. It's not h times t. So we're going to plug 15 in for h of t, the function. So that'll give us 15 is equal to negative 4.9 t squared plus 20t, and we need to solve this equation. So remember, all of our solving rules pretty much require us to start with something equal to 0. So we're going to subtract 15 from both sides here to get negative 4.9 t squared plus 20t minus 15 is equal to 0. Now, I don't know about you, but I don't want to factor something that has a decimal in it, and this thing looks really ugly. And since there's a t, not just a t squared, we can't use square root method. So what's kind of our only option at this point? We're going to go ahead and plug this into the quadratic formula. So t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is going to get a little bit ugly. Let's go ahead and grab our calculators and simplify what is in that square root. Okay, negative 20 plus or minus the square root of 106 over negative 9.8, which is 2 times 4.9. Now, this is our time t. Here's my question. How long is negative 20 plus or minus the square root of 106 over negative 9.8 in seconds? Is that like 2 seconds? Is it 100 seconds? Is it a million seconds? I have absolutely no idea. So here's what you're going to have to do. We want to know what this is, and we're going to round to one decimal place. So remember, this is actually 2 times. We've got negative 20 plus the square root of 106 over negative 9.8. And we have negative 20 minus the square root of 106 over negative 9.8. And we're going to plug both of these into our calculator so that we get decimal answers. Okay, plugging these into the calculator, this first one got 0.99, And the second one was 3.09. Are these both legitimate times that it could be that this object could be in the air? Yes. Here's my next question. Why are there two answers? Why, when I throw something up into the air, are there two times that it is at 15 meters? What's going on here? Well, let's think about it being thrown from the ground, and let's say that this is 15 meters. What does it have to do? It has to go up and then it has to come back down. So, how many times is it going to hit 15 meters? Twice.